Okay, so what exactly is Python and why do data scientists love it? So let's get into this now. So Python was created in 1991 by Guido van Rossum, and its design philosophy emphasizes code readability, and it has notable use of significant white space in its code. Alright, so you'll get used to it soon when you start with the tutorial. Basically, Python is an interpreted high-level general-purpose language. And interpreted means instructions are executed directly without being compiled into machine instructions. Those are like C++ and Java. Compiled languages, are like C++ and Java, are basically faster and they allow developers to have much more control over memory management and hardware resources. However, they are a lot more verbose, meaning there's a lot more code to get simple things done. And it's a lot trickier sometimes to get things up and running. And Python basically is so simple, and I actually find it's quite quick. You can do a lot of benchmarking in Python and realize that. It's not quite as fast as C++, but in most cases it's good enough. And this is the plus about Python, is that it's high level, so it allows us to perform complex tasks quite easily and efficiency. So why Python for data science? Now, Python competes with a lot of languages in the data science world, most notably R, and to a much lesser degree MATLAB, Java, and C++, which they all have very good data science libraries, to be fair. However, Python has much better and way more stuff. R is actually very good at statistics though, so R has a lot of plus positives here. But you can see here, this is the yellow and blue, I should say, are Python data science and Python machine learning. And you can see interest in them has skyrocketed way more than R. R is kind of plateaued and actually going down a bit here. But Python is just going up and up. So why does Python lead the pack? Now, Python is a very good general purpose language, unlike R. It supports a number of solid scientific computing libraries and has a very good ecosystem. It has a ton of machine learning and statistical numerical packages, such as these guys here, which you'll all use in this course except for Python. Python is very easy to use with IPython notebooks, and it's very handy for data scientists to share work or display work because you can see the progression. It's like a little story of the data science project, and it's quite easy to get started which you'll see in our little crash course coming up. And as it's a general purpose language, it allows us much more flexibility in integrations and building stuff like web service APIs and a plethora of other useful programming libraries. So Python is a very, very versatile, and it basically fits into any developer's workflow quite well. You can do so much with it, and it is quite fast. It's a very good language, and I highly encourage you guys to learn it. So now we move on to our crash course in Python. Okay, so you're now about to start your data science journey, and the first step to it is learning Python. So if you're new to Python, let's do our crash course. And this crash course should get you up to a pretty decent standard, I should say, in learning how to use Python, because Python is a fairly easy language to get into. However, it can get tricky as you get more in depth into it. However, let's begin. Alright, so I assume you have everything set up accordingly, as I explained previously. So there's two ways you can open this notebook. You can double click on it and click Google Collaboratory here. I have another one connected app here, so just ignore that for now. We're only using Google Collaboratory. So let's open up the file here. The other method that you can open up this file with is to right click on it, go open with Google Collab. So it does the same thing. So let's go back to our notebook here. So this is our beginner notebook. However, as you're a beginner, let's skip that. This is a good reference for you in future, but let's do a code along. So let's create a new Python 3 notebook here. It's going to be called untitled something on top. I have a few untitled notebooks, so that's why it's untitled 10. Yours might just be untitled 1. So that's okay. And let's just get familiar with the environment here in Google Colab. What these blocks are, and you're only seeing one block now, it's a coding block. So you write code and you could run it by pressing this here, or as you could see here, Control Enter or Command Enter if you're on a Mac. And they have different things, so you can add a text box here if you wanted to put notes in your file. So like just put hashtag. Hashtag basically controls the size or the heading size of it. This is a note, and you can press Alt Enter or Shift enter to run this. The difference between shift enter and alt enter, press shift enter on this block right here. Nothing happens because it's running a blank piece of code here. It should stop soon, hopefully. But if you press enter and alt, it generates one below. So that's the difference. One generates a new code block, which is sometimes convenient. One doesn't generate a code block. So now let's start with our Python crash course. So the first thing we're going to look at is variables. So I'm going to put note here, variables. This is a comment field, means that this doesn't run code. It just basically, it's like a comment in our code. So let's create a variable called a. A is equal to 14. And now let's print it. Print a. Run that, and you should see 14 below. Alright, so this is basically our first like hello world type project. If you actually wanted to do a hello world, let's just do print hello world. There we go. So basically that's what variables are. They're basically storage blocks. This could have been a string variable. So let's b equal to that and print b. So b is now a string variable. So what else can we do with variables? What is a variable, first of all? Variable is basically a container that stores information. So you can store text, you can store lists, arrays, which we'll get to soon, or dictionaries, or quite commonly numbers. So what can we do? So let's create, a was 14, right? So what if we create a variable called c is equal to 10? And let's say we want to print a plus c. That should give us 24, shouldn't it? And it did, which means that we're adding c and a together. So let's see what else we can do. Can we change variable values once they've been assigned? So let's see, a was 14, but let's make a 20, and now let's print c plus a. That should give us 30, and let's see. Yes, it does. So now let's look at the type of variables we have. So how do you know what type of variable it is? You just put type around the variable. It's a Python function called type, and it tells you it's an int. Wasn't b a string? So let's see what it says when we run for b. B is also a string, well, as expected. So that's good. What other type of variables are there? There are booleans. Just copied and pasted that from another code block. So we're making a now a true or false variable. It's a binary variable, or boolean we call. And basically, yes, it is true. Type bool. Okay. Just so you know, numbers can also be strings too. They should actually be type. And you can see here, so we're basically storing a string representation of our number. If we remove the inverted commas, it's now an int. Pretty cool. Always remember that. Don't get confused. What else can we do here? We can do some variable operations. So let's put this into here. So this should give us 14 plus 15, z should be 19, and z should be int. That's correct. Okay. How about if it was like this? What if we put the 1 and 2 in inverted commas and we try to sum them? Let's see what happens. It did sum. However, look at what it did. It basically just added the 2 and 1 together to form a 12. So if we put 101 there, we should get 1012. So yeah, so that's how string concatenation works. Basically, it just combines them together. It doesn't actually do addition like what this is doing here. So these are some simple variable operations. So now we're going to move on to list and arrays. Okay, so continuing from our same notebook, we have this text field below. I just want to show you, if you click on each variable, on each cell box, I should say, you can actually, it brings up this menu here where you can actually link to it, put a comment, edit it, or delete it. So what I'm going to do right now is actually more selections here to copy and cut. is delete this one because it's kind of annoying. Then it's in the way. So now let's move on to, well, let's actually add it back stupidly, but it's a good experiment. List and arrays, all right, which is pretty much the same thing. Arrays are basically what it's called in many other languages, but in Python it's called lists. What it is this. It's basically a container that stores multiple variables. So let's look at this here. So now A comprises of 3 elements, 1, 2, and 3. All right, and we just print it back here. So seems nifty. Why do we need this for? Now you'll see quite soon. However, I just want to show you one other feature of arrays and lists is that we can store multiple types in an array. So you would think it's only integers we can store, but no, we can store integers and text together. So I put this here to illustrate that a list basically is a container that basically stores each element here as a variable in itself. So this basically shows us that arrays and lists are quite versatile. So now, what if I wanted to print basically the first element in this list? Yeah, so it's 1. Basically, arrays or lists are indexed at 0. So 0 is the first element, 1, and since it had 3 elements, 2 would be the last element. That should be 3. And we can do this for B now as well. B had 3 variables in it, and this should print variable 2.5. So this is how we index elements here. So if you ever wanted to retrieve a value from an array, this is how we do it. We just put the big square brackets here and the index value that we want to get. Now, what else can we do with lists? What if I wanted to add a new element to, say, our list A here? What if I wanted to add, since we're going in numerical order, the number 4 at the end? That's quite easy. We can do a.append. What I want to tell you is that Google Colab is quite a nice environment to code in. It actually has these auto-completes, so if you just press tab, so you can just go to experiment again, AP, and then you have to kind of wait for it to load because it's a web-based thing. So yeah, so let's now append 4. So we've done it. There's no output in this code because all it did is just added it to the end of this array or list. So let's see if it did. Yeah, it did. So that's pretty cool. What if we wanted to get the length or the number of elements in this list? We can use the len function, which is short for length, and it tells us there are 4 elements in this list. It's quite convenient. Can we change an element in a list? What if I wanted to make, instead of starting the array off with 1, let's start it off with, say, 5. Let's see if it works. Yep, it did. So you can see you can manipulate list quite easily with these commands and these tools here. So what I want to get into now, which could be a bit complicated, is slicing. Sorry about that cough. So how we slice arrays or list in Python, we use this colon here, all right? This colon basically tells us, the first one, to print all elements. What if we wanted to get all elements from the 3rd position? So as you can see, the 3rd position in this array is number 3. So what if we wanted to print only 4? So let's see what happens. Sorry, 3 and 4, okay? Because it prints from 3 and 4 onwards. So that's pretty cool. So what if now we wanted to print all elements between the 2nd and 4th position? That's between here and here. So we want to print all elements between basically from 2 to 4. There we go. So we get 2 and 3. So as you can see, what this does, this is the starting element, and this is basically the ending element. So we don't print the ending element, we stop here. So it's like everything before here, everything from here. Same thing in this one. Okay? Now, here's another tricky one we're going to look at. This negative one, what do you think it means? As you know, This basically in comma tells us everything up to here. All right. So think about it. Okay, I'm actually spelling error here. All of this, I actually have the command here. All the elements before, I mean the note, I should say, not command. All elements before the last position. So what does that mean? What do you think is going to happen? All the elements before the last position. So if the last position is 4, we want to get all elements 5, 2, and 3. Isn't that right? So there we go. We get 5, 2, and 3. So that's what the -1 does. Basically, it's a way to tell the rate to go backwards in a way. All right. So let's make this here. Now let's move on to another very useful data type, and that is called dictionaries. So now let's just put a little note here. We're doing dictionaries now. So when you look back at it, you can see that this is what you did. So let's create this dictionary here. All right. Now there's a way we can make this look a little more legible. There we go. So here's how dictionaries work. It's a little confusing because we have something called name Japan and capital Tokyo. Now, and they're separated by a colon here. So what dictionaries are, it's basically key value maps of data. And we create a dictionary by using these curly brackets here. So name and capital are the keys here, and these are the values. So you're going to understand this a little bit more, but for now, let's just print this and see how it looks. So this will teach you a lot. We'll print the dictionary here. We just print back basically what it looked like. Then we print name. We basically put country info and name here. So basically what this does, this tells us we want all the values, or all the value here that corresponds to name, and that's Japan. And similarly with capital, we get Tokyo. So that makes sense somewhat. What just so you know, you can always add more keys and more values to our dictionary. So look, we just expanded it quite easily. And why dictionaries are useful for it, because it allows you to store like data with different fields, and it's just a nice condensed way to get data and access data out of it. You'll learn more and discuss why it comes in so handy. So let's just print this back and get it out. Yeah, there we go. So what did we just do? So we just changed the value of our population from 126 to 100 million, which is wrong. I think this is the correct population right now. So now let's add more information. Now, what if we wanted to add all these regions to it? So what we're doing here is that we're adding a new key here into our dictionary. However, all these values here is in a list. So basically we're going to put something like this into our dictionary. Look at it here. Regions has all these elements in it now. So that's pretty cool. So now let's do something else now. Apologies for that cough. We're going to add what is called a nested, or basically a dictionary within a dictionary. So here's how it looks. Now it's a bit confusing, but you can actually see there's health and life expectancy here. Okay, so what we've seen here is that now we've added another key and value to our dictionary. However, this value now is a dictionary itself. So now it is a dictionary within a dictionary, like I said. So this is getting a little bit confusing, I think, for you guys. So don't fret too much, but let's just see what else we can do. How do we access now different things? So we saw, like, if we wanted to do, let's undo that, country info. Let's get, say, our regions back out. We basically get this. What if we wanted to get now, as we just saw, our health? So what if we put health here? What happens? We get this. But what if we wanted to get now birth rate and life expectancy? It's simple. We just add in another bracket now. So basically what we're doing is that we're accessing another key within our subdictionary to get that value back out. So you've seen there how we basically mess with dictionaries now. So in summary, you can actually see a dictionary, by the keys in a dictionary, by running .keys at the end of it with open brackets. And similarly, you can actually do country.values and get all the values now. So this isn't always a sensible thing to do, maybe for small dictionaries, but this one is keys. We definitely use this a lot in Python to get the keys out of a dictionary. Alright, so that's it for dictionaries and lists. I hope you understood everything. Feel free to ask questions in the student board, or forum I should say. And let's continue now with conditional statements in Python. Okay, so now you've learned basic variables and you've learned arrays or list and dictionary data types. So you know some Python now. However, let's do something a little more cool. Let's do conditional if and else statements. So let's just put separator here. And now let's look at something very simple. All right, so what if x is equal to 19? All right, so we want to run a statement that checks to see if x is over 10 or less than 10. How do we do that? Simple. Python is a very language based, I should say, or I don't know. It's a nice language that basically, as you think of an algorithm in your head and you write it out, Python actually it forms very similar style of code in the way it's explicitly written. So that's what I should have said it before. So if x is less than 10, print less than 10. Now, we always have to combine an if with an else statement. Else tells it basically what if and else statements do is that if x, the variable in question, is less than 10, it runs this code here. So we always close with this colon here, sorry, and it's always indented a bit here. It's a very important use of whitespace in Python. And basically this is the code here. You can put multiple lines here. You can actually put 2 print statements just to illustrate that. Less than 10, yay, or something. And else follows the same thing. So else colon, and it does presented as automatic indenting in Google Colab. And let's say we print now over 10. Actually, this should be in commas here. So now let's run this and see what happens. Yep, since x is over 10, it runs this line of code here. So what if now x was 9? Less than 10. It prints these 2 lines, which is kind of redundant anyway. So what if x is equal to 10? All right, what would happen there? Over 10, exactly. And do you know why? It's because this code here is less than 10. Anything 10 and above is going to go run the else statement. So to fix that, you can just put an equal sign here. What this does, it says if x is less than or equal to 10, it does this. So that was a simple if else statement. Let's do something a little more complicated now. Let's use the elif. All right. Okay, so you're now being introduced to the elif statement. Basically, it's a third, I should say, process flow control here in our conditional loop here. Not loop, conditional statement. So what's special about the elif is that it allows us to check. With if and else, we only had 2 conditions. With elif now, we can evaluate 3 conditions now. So you can actually have multiple elifs. You can have like elif here, below, do like 5 different checks. So basically, elif is important to do multiple conditional statements here. And I'm introducing you to another concept here. So let's just run this firstly and take a look at the output. So right, it went straight to the else because this didn't evaluate to be true, this didn't evaluate to be true, and this one did. Well, didn't really evaluate it. It just, none of these options above met the criteria, so it goes straight to the else. So look at this line here. This one basically is 2 conditions in one. Is else if x is greater than 10 and less than or equal to 19. this is a way we can chain multiple conditions or have like an in-between type thing, like between values. In Python, we use AND. All right. We can similarly use OR if we wanted to. Let's go back to AND, and let's put the value here. And the reason why I didn't use OR is I'll tell you why. OR basically checks if this here is true or if this is true. Now, since we're checking to see if X is within a range, it doesn't really make sense for either of them to be true, because then we can have X is equal to 1. Say if X is equal to 1, then it would evaluate this being true and this being true, which would actually probably cause it to crash. Actually, I don't even know. It's actually a good question. Less than 10. And do you know why? Because it checked this condition first. So basically this was like a bad design, but it just illustrates that the first line was evaluated first. So now let's go back to this, and we're going to get the middle statement, greater than or equal to 0, but less than 10, which is actually should be less than 19. This is written wrong, but that's okay. Greater than 10. Yeah, but there we go. This is quite correct. So you've basically learned to do use an elif now. Now, what about using booleans? Let's take a look at this. Now, booleans, basically, you can actually save some like typing space, because you don't have to type if A is equal to true. Always note, by the way, that if you're doing like equated type condition here, you use 2 equal signs. If you use 1 equal sign, it's going to think you want to assign true to A, which you can't do in an if loop, because if you did that, it would crash. Very good. I shouldn't say crash, it would just return a syntax error. It doesn't actually crash the code. Okay, so this is true. And basically I was showing you how if statements work. It's basically if A is true, it does this. If it was false, it would do nothing. So we actually can have an if statement without else. All right, it's basically the same as writing this. Okay, so you'll probably see code, maybe my code sometimes, where I have an else and pass. However, you can just run it like this. It's the same thing. So we can see this is how we use booleans, how we use elif, how we do general if state here. So that concludes our conditional statements crash course. Alright, so now you have a fair understanding of some stuff in Python. Now let's take a look at loops. And loops are pretty cool. I actually thought they were one of my favorite things when I started programming. So let's just identify, put a break and label here. So that's loops. Okay, so first thing I want to discuss before we begin loops is the range function. All right, so let's just use range for a second. So Python has a built-in function called range, and what it does, which you will see shortly, is that it produces basically this object here, which doesn't tell us much. Should have put a list in front to show you guys exactly what it does. It creates a list basically of 4 elements from 0 to 3. So basically this is important, and you'll see why. All right, you basically use it to generate a list here, and the list always starts at 0. If you wanted to start at 1 for some reason, we can run it like this, and there we go. So here's why. So when we build for loops in Python, we build it like this: for I in range, as you can see here, and I'll tell you why again we use range. Let's say 1 to 5. Again, we use the colon there, auto indents for us automatically, and let's print I. So what happened here is that what this for loop does, now you need to break it down carefully. This for loop here creates an element or a variable I, and basically it increments I. I shouldn't say increments I. Basically what it does, it takes the range here, which is these elements we created here, and assigns each element to I. So now this loop will run 4 times, and each time I takes a value within range here. So if we were to put range to say 0 to 5, this will run 5 times, and it'll start at 0 and end at 4. So this is how for loops work. We control the amount of times we run it here, and basically we use I as our incrementer, you can say, that basically takes the values here. So why is this important for? Now let's take a look at this. Now let's create an array here, or a list of items, and these items are going to be string variables. So let's go A, B, C, and D. Alright, now here's a magic in Python with loops. For item, remember item is a variable that it's like a blank variable that takes the role, basically of I takes the value of the list objects in range here, generated by range. So now what if we did it for I in items? What would that mean? That would mean that, say if we print item, every value, in items, this array, item is going to take each value at a time. So it's going to be A, going to be B, going to be C, going to be D for each run. So it runs 4 times, and it's going to print A, B, C, D here. There we go. So this is how we do loops or for loops in Python. This is extremely useful, although it confuses a lot of beginners. So try to understand how it works here. So now let's look at something else here. Let's look at something a bit more complicated. So let's see what we're doing here. First, we're declaring a variable x being 0, and then we're creating a blank list here called collecting values of x, So what's going to happen now is that we have our same array of items here. Now every time we run this loop here inside, we want to increment x by 1, and that's what this says here. This plus equal sign means that every time this runs, x increments by 1. And actually it doesn't even need to be run. Let's just run, we need to be in a loop. It can just be done by itself. So if x is equal to 0, let's print x. X is 0 here. Let's add another code. And now let's do this. This should mean x should be 1 now. This line is the same as saying x is equal to x plus 1, by the way. So basically what it says here is that x, which is 0, plus 1, is now the new value of x. So that's what this is short for. So I hope it doesn't confuse you. And lastly, we're going to print x in item. So we're going to see how x progresses or increments as a loop every time the loop runs. And lastly, we're going to append x to this variable here. This is going to collect the values of x. So every time this loop runs, it's going to put x back into this list here. So let's take a look at this magical little loop here. Exactly as we expected. So it prints 1, 2, 3, 4, which is x being incremented from 0. And then what it does, it prints item, which is A, B, C, D, right here. And basically now you can see collecting values of x has all these values here, 1, 2, 3, 4. So pretty pointless piece of code, but it's good to illustrate some important concepts. So now let's take a look at while loops. While loops are not that frequently used in Python, I would say, but it is important to know, and I actually have used it quite a bit in some of the code. So let's see this here. So x starts off at being 0. So while x is less than 5, we increment x every loop run. So it starts at 0. So it's going to be 1 here, then 2, then 3, and then 4. But then which is 5, and 5 is not less than 5. If it was less than or equal to 5, it would be okay. But let's see what happens. And do you know what it happened for? It's actually not what I said would happen. And I was wrong, because what happens here is that it was 4, and it ran right before. And what happened is that now x comes into the loop as being 4, which is less than 5. But then we auto increment x here immediately, so x becomes 5, and now the loop stops when it's 5. So x became 5 before it actually checked here. That's why it is a 5. So it's interesting, and probably should have told you the correct thing at first, but it's good to sometimes see little things like this and take note of it. So now, what if we made a loop like this? While true. While true loops run forever until something stops them. And that's something we can call is a break statement. It's another Python built-in function. What it does, it tells if a break statement runs in any loop, it automatically stops the loop, whether it's a for loop or while loop. So just like this other code here, we're incrementing x by 1 every loop iteration. And then what's going to happen is that as soon as x is equal to 5, it's going to break. So it's never going to even reach this line. So this loop shouldn't reach 5, although actually it will, because it's going to become 5 before it actually reaches this line. So yeah, let's see. Yep, exactly, it does. So it's pretty cool. So now we can see there's another way to stop loops here. This way is a little more efficient, but this way is also possible and usable if you have multiple break conditions. So that concludes our section or crash course in loops. Hope you understand, and keep messing with it, keep making your own code. It's quite fun to do, and you'll get a hang of it quite quickly, trust me. Alright, so now let's move on to functions. So let's just create a little break here. Actually, this should be text. So what exactly are functions? Now, functions are part of like object-oriented type programming. They're a small part of it. Classes actually form the bigger part, which we'll do very, very shortly. However, functions basically, remember how we have the print function in Python? This is print. Print basically is a built-in Python function. We can make our own functions, which is what we're going to do. So let's make a quick function to find the area of a circle. So if you remember from high school maths, area of a circle, or even primary school maths, is pi r squared. So let's make a function. So we define a function by typing def, and we call this function area of a circle. And now the input would be the radius, because pi is a constant and square isn't an input, just an action or operation. So we do the same colon thing there, and it auto indents. So now we put area here is equal to 3.14, which is pi, multiplied by the radius to the power of 2. This is how we do exponents in Python. And then we return area. So we run this, it doesn't do anything, but what it actually does is it stores a function here in Python, in our code shell, I should say, so that we can reuse now. So now this is a function here. So let's say the radius was, say, 2. Voila, we got the actual area now. So this is pretty cool. So quick thing I should tell you is that we didn't actually need to define a variable for area here. We could have actually made this function even shorter and put this into the return statement here, save a line, and it works exactly the same way. So now let's do a more complicated function where we actually find a volume of a cylinder that has 2 inputs. Now, one thing you should know is that how functions work is that we define the input arguments here. So whenever you put 2 here, the function actually takes radius as being equal to 2. You can actually prove it by doing print radius here, and now it'll actually print 2 inside, because the print statement was called inside the function. So you can actually see print 5, it'll take 5. So you can actually see the value being transferred inside of the function and being operated on. So the same can work with 2 variables, radius and height. So let's do something else too as well. So let's define this function in our Python shell, and we can actually explicitly state here, you don't actually need to put radius equal 5 or height equal 5, but it is a good practice to do sometimes, because it is helpful to know that for code readability per se, it's helpful to know what you're putting 5 and 6 to. Because let's run this and see what happens. Let's assume this is correct. I haven't double checked it, but it should be. So we can actually run the same thing with 5 and 6 here. Now, as you can see, just putting 5 and 6 here, kind of like if you're reading this code, someone's code here, you wouldn't know what was what here. You wouldn't know which was radius and which was height, but if you write it here like this explicitly, you actually do know. So here's another key thing you can do. Let's look at this here. We can actually put radius. Suppose the cylinders were all of the same radius. You can put radius is equal to 3 here. Alright, define that function. Actually, this is wrong. I'm stupid. All of us make this mistake. It has to be at the end here. This is where you actually set the values here. Now, actually I should have left that error for you to understand. But basically what it says is that whenever you're putting default values in a function, it has to be in the latter side here, not in the beginning. So while this is running and taking a while for some reason, there we go. Occasionally, because my internet in this apartment isn't the best, it's BT. For UK guys, you'd know BT sucks. It's not fiber, but that's, I mean, there's BT fiber, but I don't have fiber. But it's okay. It's about 20 megs. It's usable enough. Anyway, so what we can do with this now is that since we have a default argument being 3 here, we actually don't even need to enter that there. You can just enter volume and it works it out. You don't need to enter height. Whenever height is missing, it takes on the default value 3. However, you can actually change it to 10. So now that we have a value here, it no longer defaults to 3. It'll take this new value 5. So that is quite cool.
Subscribe now and press the bell icon. Never miss an update.